All right, folks, so let's go ahead and jump right into today's notes. We're doing domain and range. And what we're going to do is we're going to identify the domain of a function algebraically, and then you will write the domain and range in interval notation. We're actually going to go to interval notation first because I think it's a better starting point. So you're going to skip past the first 2 pages. And on the 3rd page, it should say interval notation at the top. If it doesn't, that's okay. It says interval notation. Okay, so we have our inequalities on the left here. And so what we're going to do is we're going to graph first, and then we're going to put it in interval notation, which for some of you it might be new, for some of you it might be a review. So hopefully it's a review. Okay, so if I have an inequality, x is greater than b, b could be anything. It could be, 10, any number. Here I'm going to put b on my graph. And what this is going to look like is I have a greater than symbol, so x is greater than b, and so I have an open dot. Remember, if you have these 2 symbols, it's open, and if you have these 2 symbols, it's closed for your graphs. So I'm going to have an open circle going to the left. I'm sorry, the right, because it is x is greater. So anything greater than b, let's say b was 10, then it would be 11, 12, 13, all the way up, and everything in between. And the reason I draw the squiggle is just so that you can see a little bit better than if I drew over top. Okay. If I have x is greater than or equal to b, then it's the same graph, except because I have this little underline there, I'm going to fill it in. A is the same thing, just the opposite direction. So x is less than a is going to be a with an open arrow going to the right or to the left. I don't know what's with me today with my lefts and rights. And then a closed circle going to the left for x is greater than or equal to a. All real numbers. So for all real numbers, that's going to be the whole dang line. And then for x is between a and b, or otherwise known as a is less than x is less than b. If I have a and b, then the way I would write that is an open circle, and then it's going to go between them, so everything in between there. And pretty much it's going to be the same graph over and over again with mild verifications, since we do have these compound inequalities. So I'm going to go ahead and speed through these. So we have, dang it, it's a different color, whatever. So for this one, I'm going to have a closed dot on A. I'm going to maybe leave this different. Closed dot on A, open dot on B. And everything in between. For this one, I'm going to have an open dot on A, a closed dot on B, and everything in between. And then finally, closed dot and closed dot on A and B. And it will be everything in between. Okay, so let's go ahead and jump to how we would write these in interval notation.
Ms. Cruz, please report to the library with your computer. Ms. Cruz, to the library.
All right, so the picture of the graph really helps us with how this is supposed to look. So if we look here, we've got B is going from, we've got our numbers going from B, and then they continue going up all the way. It's, like I said, so it's like 10, it's 11, 12, 13, 14, and it keeps going and going and going. When something keeps going, it's going towards infinity. So interval notation, we would write it as B going to infinity. So when we have an infinity, we always use a parenthesis. So I'm just going to make a note of that. So this always gets a parenthesis. All right. If it's a closed circle, or let's do open circle. If I have an open circle, always gets parentheses, and a closed circle always gets brackets. I may have said that wrong, but I have it written down correctly. Okay, so since I have an open circle on B, I'm going to have it written like that. For B goes to, for X is greater than B, we can see from the graph that B is going, starting at B, and it's going up and up and up to infinity. So we always have an open, oh, what the heck? Didn't know I could do that. An parenthesis on infinity, because we always get in a parenthesis, and a closed dot always gets a bracket. Right? I'm going to go ahead and jog through these really fast. Doop. Okay, this next one is going from negative infinity to infinity because it's all the numbers between negative infinity and infinity. And again, those get the closed, or I'm sorry, those parentheses. These next ones are a little bit, I'm not gonna say trickier, but they're a little bit more interesting because they don't have infinity in them. So this next one here, we have basically all the numbers between A and B. So really our first number is going to be where it starts, and the second number is going to be where it stops. So it starts at A and it stops at B. And then we just have to pick which bracket it is. And we always want to move from left to right. So from left to right. All right, so A is going to be an open circle, and B is also an open circle. So we have those we have the parentheses. We have A and B for this one as well. For this one, we have a closed circle and an open circle. Right, this next one I want you to try on your own. I'm going to put a question in the video right here. The answer to this one is open circle for A, closed for B. So we have parentheses A, B, bracket. And then finally, we have 2 closed for the last one there. All right, so now I think, yep, we're finished with that interval notation. So we're going to go ahead and go to the very beginning. The interval notation really should have been somewhat of a review for you. All right, so now we're going to focus on finding the domain of a function. And it all stems from 2 questions, or really one big question. Is there anything that x can't equal? Sorry, a question mark there, but I don't even care. All right, so from there we have 2 questions. Is it a fraction, and is it an even root? I'm always going to ask myself those 2 questions when I'm asked to find the domain. So my first one, if I have a fraction, if my answer is yes, then I set the denominator not equal to 0, and solve. Or, in other words, you set it equal to 0 and eliminate the solution. All right, my second question is it an even root? If it has an even root, which would be like the square root, the fourth root, sixth root, so on. If that answer is yes, then you're going to set the radicand greater than or equal to 0 and solve. So for those that don't remember what radicand is, that's going to be the stuff under the radical. All right. Then finally, or not finally, if we have both of those things, if we have a fraction and a radical, like in example 3, then the domain, oh, that's not what I meant to say. If we have yes to both right here, then we're just going to combine our answers. But if we say no to both, then the domain is all real numbers, otherwise written as the double-barred R, which from here on out is all I'm going to write. Pause if you need to. I'm moving on. All right, so we're going to find the domain of each of these functions, and we're going to talk through it just like I did before. So use the chart. It's very helpful. I've used it in years past, and kids really loved it. So first question, is there a fraction? I see no fractions, so no. Is there an even root? I don't even see a radical, so no. So my answer is all real numbers. Question number 2. All right. Oh, I forgot something. We have to do interval notation. So you can use your chart if it's helpful. All real numbers is all the numbers is what it is. So it's going to be all the numbers between negative infinity and infinity. And remember, we use parentheses. Sorry for the noise in the background. Can't help it. All right. So do we have a fraction in this one? Number 2. Yes, we do. So what we're going to do is, that's a pretty color, is we're going to set our denominator not equal to 0 and solve. Okay, so subtract 1 from both sides and I get x is not equal to -1. All right, I have to ask myself another question. We're going to save this for later. Bloop. Do I have an even root? There's not even a square root in there or any kind of root, so nope. Okay, so now I have to turn x does not equal -1 into a interval notation. When I first started with these, I always drew a number line because I found it really helpful. So here's -1. The open circle means that it's not included. So what I'm going to do is I'm going to put an open circle on -1. Now, then I ask myself, can -2 be on there? Yep. Can -3? Yep. Can everything between -1 and -2? So like -1.5, -2.5, -1.111. The answer is yes. So it's going to be everything to the left of that. And then 0's included, 1's included, 2's included, all the way up. So it's going to be everything to right of that one too. So let's just focus on the left here. I wish there was like a way I could like cover up half of the anything
Ms.
easier.
Connor, please report to the library with your computer screen. Ms. Connor to the library.
Goodness. Okay, so I'm just gonna kind of cover this up for now, just so we can focus on the left. So before, when we had something like this, we would write it as, we have everything go from negative infinity up to 1. Remember that negative infinity is not included. And we can also see that negative 1 is included, but it stops at negative 1. So that's how we're going to write that piece of it. Then, oh, I thought that made, let's see. Oh, that was perfect. Okay, so then it's going to be everything to the right of 1, negative 1, not including negative 1, all the way up to infinity. So we have these two pieces that don't connect. So we write two different parts and then put the union symbol between them. All right, let's go on to, let's actually do number 5 first. That way we can work on that before we jump to a harder problem. Okay, so I have the square root of 3, square root of x plus 3. So that's an even radical. It's probably not correct. Dang it. Even radical. Just noting that from the very beginning, but I'm still going to ask my questions. Do I have a fraction? No. Do I have an even root? Yes, I do. So I'm going to follow my steps for the even root. What I have to do is I have to set x, the radicand, x plus 3, greater than or equal to 0, and solve. So subtract 3 from both sides. Get x is greater than or equal to, ooh, that's ugly, greater than or equal to negative 3. Okay, so that right there is my answer. And so I'm going to work on the interval notation by drawing the line, the number line here. Okay, so we're going to put negative 3 on here. Put some other numbers just for a show. Negative, oh, I did that backwards. Negative 3, negative 2, negative 1, negative 4, and negative 5. All right, so we have a greater than or equal to symbol. Remember these two get a closed dot. So I'm going to put a closed dot on negative 3. And I like to think about it. I'm like, is negative 2 greater than negative 3? Yes. Is negative 1 greater than negative 3? Yes. And everything in between those is also. So it's going to be everything to the right of that negative 3. You'll also notice that this points right. Just a hint there. That hint only helps when x is on the left, by the way. And then negative 4 is not greater than negative 3, so it's not in the interval. So the way that I would write this interval is I'm going to have a closed dot. I have a closed dot on negative 3, so I'm going to have a bracket for negative 3, and then it goes all the way up to infinity. So I always write from left to right, my starting point and my stopping point. Okay. Let's go ahead and do number 3. Thinking for a second. Yeah, let's go ahead and do number 3. So number 3, we're going to have ask ourselves the two questions. Is there a fraction? Yep. So I'm going to write this as a to the denominator is not equal to 0. So then x cannot equal 7. Then I'm going to ask myself, is it an even root? There, in fact, is an even root. Yes. And so I'm going to put what's the radicand, x plus 5, as greater than or equal to 0, and solve. So if x is greater than or equal to negative 5. I have two parts, and I'm going to put them together now is the next step. So what I'm going to do, I'm a little low on space here, so I'm going to work off to the right. I'm going to make my number line. And I somehow need to get negative 5 and 7 on there, so let's just put negative 5 down here, positive 7 right here. You don't have to like fill out the whole thing. It's not worth your time. All right, so I'm going to have this tells me that I'm going to have an open on 7. So I'm going to have an open on 7. All right, that's all it tells me, and then it tells me I can do everything else. Wait a second, because this right here says it's going to be closed on negative 5 and everything right. So I have a closed on negative 5 and everything to the right. But we already know that negative 7 does not get filled in. So it's everything to the right but negative 7. So fill everything in but that. Okay, so this picture right here is going to help us write it in interval notation. Now we have two different intervals. We have the one from negative 5 to 7, and then we have the one from 7 to infinity. So what I'm going to do is, so starting from the very, very left, because we always want to work from left to right. So starting at the very left, I'm starting with negative 5, and it's a closed circle, so I want to bracket. Then we go up to negative 7, and then we have to stop. And it's not included, so we're going to use a parenthesis. Then we're going to use this little union symbol again to tie them together. I picked up my pencil at 7, and I set it down on the other side of 7. And then it goes on up to infinity. Okay, so one way of thinking about it is I'm going to put my pencil down and drag it, but I don't want to hit any white space. So I don't want to hit this white space over here. I'm starting at negative 5, starting at 7. Oop, can't hit 7, so I'm jumping over and going the rest of the way. Okay. All right, so this next one here is going to be a little bit more challenging, but this is the one I want you to do it yourself. Boop, do it yourself. So pause the video here, and it'll ask you a question. I'm going to go ahead and run through it now. All right, so we have a fraction. Yes. So what I'm going to do is I'm going to write the denominator, the square root of x minus 5, not equal to 0. All right. To solve, what I have to do is I'm going to square both sides. So square that, square that. When I square the square root, they cancel out. So I'm left with just x minus 5. And when I square 0, I get 0. And then I just solve the rest of the way. Super easy. So x is not equal to 5. Then I ask myself, is there a radical? Sorry, not just a radical, an even root. Yes, in fact there is. So what we will do is set the radicand x minus 5 greater than or equal to 0. and solve. So I have x is greater than or equal to 5. Oopsie daisy. All right, so I have these two pieces, and they're somewhat conflicting. How can something be both equal to 5, because it's greater than or equal, oh, gee, that's why I was confused, greater or equal is what that means right there. But this is not equal. So if we combine those two ideas, what do we get? We get that we have greater and not equal, so it's just greater than. So to write x is greater than 5. Now the reason we had to think through that was because of this equals to 5 right here.
Please report to the library with your computer. Can you see user to the library?
All right, so we have x is greater than 5. You could have figured that out using the number line. It's a little bit more confusing, so let's go ahead and create our number line with 5 on it. We've got an open circle on 5 and everything to the right. So then we would write that as 5 to infinity. If you didn't get that right on the question, that's okay. It was a little bit more challenging of a problem, but it does help me kind of figure out where you are in the process. All right, everything's kind of small. I want to zoom out, but all right, finally, number 6, note that we have an odd root here, okay? Ask yourself, is there a fraction? Nope. Is there an even root? Nope. So the answer is all real numbers, or negative infinity to infinity. All right. That is all for today. Thank you for your